Hi there, in this video we're covering a viewer-submitted question from their homework that they wanted a little bit of assistance with. Now this is a quadratic word problem, and while we have covered a variety of quadratic word problems on this channel, this is actually a unique one we haven't covered before. The question is, the length of the hypotenuse of a right angle triangle is 1 centimeter more than triple that of the shorter leg. The length of the longer leg is 1 centimeter less than triple that of the shorter leg. Find the lengths of the three sides of the triangle. Now while we haven't covered this type of question before, it will still follow the exact same steps for any quadratic word problem. The first step being draw diagrams and define variables, the second step being construct quadratic relationships between variables, the third step being determine what you are solving for, the fourth step being solve for the variable or points of interest, and the final step being solve for additional variables or points of interest and make a concluding statement. Let's look at the first step here, draw diagrams and define variables. So in this situation, we're looking at a right angle triangle. So we have a hypotenuse we'll define as h, we have a longer leg which we'll define as L, and we have a shorter leg which we'll define as S. The next step to solving this problem is probably the hardest part of any quadratic word problem, and this is constructing our quadratic relationships between variables. So what do we know in this problem? Well, we know that the hypotenuse is 1 centimeter longer than triple that of the shorter leg. Or algebraically, we could write this as the hypotenuse is equal to 3 times the shorter leg plus 1. The next thing we know is that the longer leg is 1 centimeter less than triple that of the shorter leg. So once again, algebraically, this would be written as the longer leg is equal to 3 times the shorter leg minus 1. The final thing we know is Pythagorean Theorem, so the hypotenuse squared will be equal to the shorter leg squared plus the longer leg squared. Now we've actually defined the hypotenuse and the longer leg in terms of the shorter leg in our equations above. So we can simply sub these into our question here, and what we see is now we have everything as s. There's only one variable in our equation, and that's exactly what we wanted to do. Now all we need to do is simply expand these brackets, collect like terms on each side of the equation, and then it's a lot easier here to move all of our terms to one side of our equation. So if we do that, we're left with the expression 0 equals s squared minus 12s. The next thing we need to do is to determine what we are actually solving for. In quadratic word problems, there's two different types of things we need to solve for. If it's a maximum-minimum question, we need to solve for the vertex, or if it's a solve for a variable question, we need to solve for the x-intercepts in our quadratic relationship. Now in this case, we are solving for the variables, so we're going to need to solve for the x-intercepts. More specifically in this situation, we actually need to solve for s by factoring or using the quadratic formula. In this case, factoring will be much easier, although both techniques are completely valid. So now that we know what we're solving for, let's solve for it. So, looking at this expression, the first thing I would want to do is look for any common factors. We can actually common factor out an s from both of our terms, and interestingly, this is already completely factored after this one simple common factoring step. And this is why factoring was much easier to do than the quadratic formula in this case. While the quadratic formula would work, it would be a lot more steps. So the values of s that satisfy this expression are 0 and 12. Now 0 doesn't make sense in the terms of length of a triangle, so 12 is the answer we're actually looking for in this case. Now the final step is we just need to solve for additional variables and make a concluding statement. In this case, while we've already defined what the value of s is, we still need to find the other two side lengths of our triangle. The easiest way to do this is simply sub this s term into our original two equations and solve. If we do this, what we get is a hypotenuse of 37 and a longer leg of 35. Therefore, the side lengths of our right angle triangle will be 12, 35, and 37. Thank you again to the viewer who submitted this homework problem, as this is a very unique type of quadratic word problem I personally have never faced before. But you can see that following the exact same steps as we have for all of our other quadratic word problems, we were still able to get to the answer fairly easily. If you found this video useful, please check out my playlist that covers a wide range of different quadratic word problems. This video will also be linked to that playlist. I have a complete guide, as well as a variety of YouTube shorts that cover all the different quadratic word problems you might face in a quick 60-second format, and this is great for reviewing right before a test or an exam you might have coming up. Thank you again for your time, and I hope you can tune back into my channel soon.